Now, 2 points to make. First, this CONH bond, there are 2 ways that I could have drawn this bond, right? I could draw it in cis, or I could draw it in trans. Now, am I showing it here in cis or trans? Raise your hand if it's in cis. Raise your hand if it's in trans. Of course, it's in the trans configuration. And I'm showing to you, in general, the trans configuration and the cis configuration. And you can see exactly what the problem with the cis configuration is. Let me show it to you in one other way. This is pi mole that you will have a chance to use yourself. Build residue. We'll make an alanine leucine dipeptide. Leucine, we'll say, show sticks. Okay. So here's our trans peptide bond. Here's our carbonyl. Here's our NH group. Here's our alanine side chain. Here's our leucine side chain. Notice how far apart they are. This is pointing in one direction. That's pointing in the other. You can see, right, that if I flip this bond, if I make this bond in cis, I'm going to pull this side chain very close to this side chain. It's going to be overlapping with it. And that's the problem. And that's what I'm trying to illustrate here, where you see that the R groups, which are far apart in the trans bond, are very close in the cis bond. And you can get a flavor for that here. So in general, most peptide bonds that we talk about in this course, by and large, are in the trans configuration. So this bond is usually in the trans configuration. There's one example where it's not so bad to be in the cis configuration, and that's if the bond involves an X-proline bond. So if I have X amino acid bound to proline, as I will show you shortly, because the side chain of proline comes back around on itself, there's not that much difference between the cis configuration and the trans configuration. So bonds with proline sometimes are not in the trans configuration. Sometimes they're in the cis configuration.